Okay, we have 3.1. We're going to solve our systems graphically. First of all, a couple of vocabulary words. Systems. Systems are two or more equations. Now we're going back to lines from chapter 2 where we did single lines. Now chapter 3 we're going to be doing a system of lines. So a system means two or more lines. The solution is going to be the ordered pair that makes both lines or both equations true, meaning I could substitute it in and I could find it algebraically that it makes the equations true. Graphically, we're going to see that's where they intersect. But what's most important is that it is an ordered pair that satisfies both equations. In order to graph, it's exactly the same way we do it as if there's one line, meaning we have to have it in slope-intercept form, y equals mx plus b. We're going to graph both lines on the same axes. And then where they intersect, that coordinate point, xy, is going to be the solution. Now, whenever we graph, there are three types of possible solutions. The first solution is the obvious one, is where two lines cross, and it is some x comma y coordinate point. They meet at one single point. The next one is if I were to graph both lines, they are on top of each other, and if both lines are on top of each other, it means they are the same line, which means they have every single point as a solution, and we use the double-barred R to mean all real numbers. All real numbers means absolutely everything is shared. So in this case, if they are the same line, they have all the same points, they have all the same solutions, it's all real numbers. And our third type of solution is when I graph them, they're parallel lines, they never intersect, they never touch, therefore they have no solution. So we have three options. We can have one, all, or none when it comes to types of solutions. The first thing we're going to look at is we're going to look at how to find if an ordered pair is a solution. So is an ordered pair a solution? Well, first of all, you have to have your equations and you have to have the ordered pair. So here we have the ordered pair of -3, -5, and we're wondering if it's a solution to the system, because there's two equations there. If it's a solution to the system, -x -y equals 8, and 2x plus 5y equals -31. If we want to know if something is a solution and we're not graphing, all we have to do is substitute. Substitute in the x and the y, and then simplify down the equation. When I put it into the first equation, when I put -3 into the x and I put -5 into the y, I get that the left side equals the right side. And when you show me this substitution, you need to show me the left side equals the right side. If you stop at 3 plus 5 is 8, that is not proving anything. You need to prove all the way down the left side is the right side. All right, so then I take 3 -5 and I'm going to plug it into the second equation. And when I plug it into the second equation, I get the left side equals the right side. That checks. So I would say yes, it is true in both. Therefore, -3, -5 is a solution. Okay, so let's take a look at 3, 0. Is 3, 0 a solution to the system -x plus 2y is 3 and 10x plus y is 30? We plug it into the first one. -3 3 into the x location and 0 into the y equation. And once I do that, I get -3 is 3. It's not a solution to the first line. Well, if it's not a solution to the first line, it doesn't really matter for the second. You could stop at this point. However, if you wanted to go on, you could, but it doesn't matter. Even though it was a solution for the second, it wasn't a solution for the first, and if it's not a solution in one of the places, it's not a solution for the whole thing. So if it's false in one, it's false for the whole thing. It's not a solution. So that's the first way we're going to check it, is we're going to just substitute in. And we're going to come up either the left side equals the right side or it doesn't. The next way you're going to do it is you're going to look at graphing. When you're going to graph and see, is it a solution, you have to first put it into slope-intercept form, of which we've stated now several times. Once I change my equations into slope-intercept form, y equals mx plus b, in both of them, subtract the x, divide out the coefficient of y, then I get to graph them. When I graph them, I need to make sure I have enough points so they intersect. Start at the B, 13, down to right 1, 2, 1, 2, 1, 2, 1, and keep going. Start at negative 1/2 and up 5, right 2, 5 and 2, and you keep going and going and going until they intersect. Now, you're doing this on lined paper. You're doing it on graph paper, so you're going to see your points really clearly, as opposed to my hand drawing. And then you get to find out where they meet. And where they meet is the solution. In this case, they meet at the point 3, 7, of which on graph paper you should see that a heck of a lot more clearly than what you do by hand. So the first part of the assignment that you're going to do on 3.1 is that you're going to check, is it a solution? And you're going to solve the systems by hand, by substituting, or graphically.